Assalamualaikum warahmatullahi wabarakatuh. We are from Team Garuda. Today we are here for Garuda team final presentation, application of eco-friendly material for high alloy strength concrete. International Concrete Competition 2023. We are from Dr. Stomo University. May I introduce myself? My name is Muhammad Suhal Firdaus. I am the leader of Team Garuda.
And my name is Ahmad Masya.
My name is Abid Molidan Akbar.
Our title of this presentation is Maximizing of the Optimization Chemical Reaction Effectiveness for High Alloy Strength Concrete. Application of eco-friendly material for high alloy strength concrete. Next. Previous Garuda's project, we are aims to effectiveness increasing for compressive strength is approximately for 6%. The result of effectiveness life cycle analysis is with percentage of 6%, 9% approximately, and the result of its effectiveness from reducing waste material is above 24%. Next. So this is the diagram of effectiveness compared to normal concrete. And this blue is effectiveness increases for waste material reduction, gray for effectiveness increases for life cycle analysis, and the dark one is effectiveness increases for compressive strength compared to normal concrete for Garuda concrete. Next. The content of this presentation is background, materials, consideration, methods, discussion, mediation, LCA and RCC analysis, and the last is conclusion.
The first element will be explained is about the background. Based on data compiled by Climate Watch in 2023, which is the taken our work in data is explained, the buildings and the manufacturing and construction is the one of the largest of carbon dioxide emission in the world. So that's why the innovation is needed to reduce the carbon dioxide emission. So each year, more than 4 million tons of cement are produced, accounting for around 8% of global carbon dioxide emission. The next point will be discussed is about materials. There is some materials that we use in our innovation concrete. The first one is ordinary Portland cement or OPC. And the second one is bottom as fine aggregate substitution, and the calcium carbonate or CaCO3 as a cement substitution. And we have a fine aggregate and a coarse aggregate, which is both of them is the general materials in the concrete mixture, and the other waste material we use carbon waste for the cement substitution. The reason we use eco-friendly materials will be explained in the next slide. First, calcium carbonate. The reason we use calcium carbonate because calcium carbonate contains a lot of calcium oxide, which plays a role in the high alloy strength, and that can make a concrete more strengthened and more rigid. And carbon waste. The reason we use carbon waste because carbon waste can reduce the cement composition and also can reduce the environmental impact. And the usage of carbon waste must around 5% of cement. The utilization of bottom ash because we use bottom ash is for waste material, for reducing waste material, and bottom ash is from results of combustion coal process, and this is a B3 waste material that can be polluting in environmental. The next is super plasticizer. The usage of super plasticizer is for reduce stiffness due to lack of water and can increase the slump value. But the usage of super plasticizer must be in the right dosage because if used excessively, it will cause segregation and bleeding.
Okay, the next slide is method that we use. Next. For the method that we use is for reference American Concrete Institute 211 method, and using several journal as our reference and combining with our trial and error. Next. And in the next is discussion. In this slide we will discuss about the material that we use besides of using being used as material substitution. And this is calcium carbonate besides being used as cementitious material. We use calcium carbonate as a filler because the size of the particle of calcium carbonate itself is very small. And the other reason we use calcium carbonate is because the calcium carbonate is contain a lot of calcium oxide that which plays role in high strength. Next, and we said of in this slide the bottom mass itself. The utilization of bottom mass is to reducing the waste material of steam electric power station, and usually the waste of steam electric power station is disposed of in landfill. Next.
And then the effect of adding eco-friendly materials. Next. Calcium carbonate is Cal3 plus H2O is resulting calcium hydroxide plus carbon dioxide. Carbon waste is CaC2 plus 2H2O is resulting in C2H2 acetylene and calcium hydroxide. Bottom as SiO2 plus AiO2O3 plus Fa2O3 is resulting 3 calcium silicate plus tetracalcium aluminum fluoride iron oxide. Next. The reaction can be described as follows: Cal3 plus 2SiO2 plus Al2O3 plus CaOH2 plus 6H2O is resulting 3CaSiO2 plus CO3 plus 2SeOH4 plus F plus 4H plus C4AF. The calcium ions. Next. The calcium ions in calcium carbonate react with the silicate ion in cement to form a calcium silicate hydrate, which is a gel-like substance that fills the pores and voids within the cement paste. Over time, this gel-like substance reacts with the surrounding cement particle and carbon waste as a filler, will bottom us help to form a more rigid crystalline structure for give strength and durability to the final product. Next.
Okay, the next we will explain about mix design. Next. And we decided to use the reference of mix design by SNE 036468 and 2000, and combining with our trial and error evaluation. And the weather usage ratio is 26% for metal content such as cement plus calcium carbonate and carbon waste. And we're planning the slump flow value is around 600 millimeters until 800 millimeters, and the circle diagram shows the mix design proportion of our mix design. Next. And for mix design proportion, ordinary coarse cement is 16.2%, and for coarse aggregate is 35.6%, and for fine aggregate is 35.4%, and for water 5.6%, and for calcium carbonate is 4.6%, and for carbon waste 1.1%, and for bottom ash 0.7%, and for superplacer 0.5%. Next. The next is for type of concrete making methods, and the first we do research journal and several reference, and the next we do research for eco-friendly material, and then material preparation. And for for normal concrete mixer and eco-friendly material, and the last is supervised design. And then we calculate mix design for 15 MPa at 1 day old. And then we trial mix design, and then we do some tests and do a trial in cylinder for work. And then we test the compressive strength of 1 day old concrete. And the last is a process if our mix design meet the requirements or no. Next.
So the next is the strenuous planning. We plan about 3 mix design in here. Mix design 1 is planning for 14.3 MPa. Mix design 2 is for 15.14 MPa, and mix design 3 is 6.9 MPa. And this is the references based on ACI 318. Next, our trial and error result. The trial error for mix design 1 is about 14.1 MPa. The trial of mix design 2 is about 16.4 MPa, and the trial of mix design 3 is about 11.8 MPa. And we decided to make the mix design number 2. Next.
And the next is life cycle assessment. Discussion on LCA in this presentation will be limited to those well-defined impact categories with established characterization or equivalence vector such as global warming, solid waste, hazardous and radioactive waste, and also ozone depletion. And we will next. And this is the annual emission of carbon dioxide from cement production, and it's increasing in every year. Next. And the next is annual consumption of antibiotic substance, and carbon becomes one of the contributors. Next. And the next is the average temperature anomaly, and it's increasing in every year without the decreasing of the ozone layer, and cement production is one of the contributors. Next. And because the cement industry are the one of the contributors, the cement industry utilizes supplementary cementing material or SCM such as fly ash, silica fume, limestone water, and etc. And based on research from Maisara Ali, the replacement of cement by just 2% calcium carbonate helped to reduce the carbon emission from cement plants by 69%. Next.
For the LCC analysis, the data that we shown in this slide is according to our proposal. But with actual usage, especially supervised disaster, we just use around under 7 kg per meter cubic, and this is reduced around 300,000 rupiah or $20. And this innovation concrete, the price is more cheaper than the normal concrete, and this innovation concrete is more and is more environmental friendly than normal concrete.
Plus this explanation, chemical properties that contain on calcium carbonate and carbide waste is the most plentiful is calcium oxide, which is the reactant to first reaction that affected on early stage. And the chemical properties that build up the most bottom mass is silicon oxide, which is contributing to second reaction that affected to middle stream. This concrete is more environmentally friendly than the normal concrete, which is beneficial to reduction carbon dioxide emission. This is proven by the reduction of cement with replaces of calcium carbonate and carbide waste as cemented to cement. This concrete is using this material as well as carbide waste and bottom mass, whereas the material should be pollute the environment, and one of the hazardous material is categorized for B3 level of hazardous waste material. Nevertheless, the material can be utilized from the chemical aspect for the result of reducing waste material pollution.
Repeat, time is up. Team Garuda. Thank you for the presentation. And now we'll enter the interview session for the honorable juries. First, Ms. of Irwin to do the interview for 5 minutes.
Okay, thank you. Assalamualaikum. This is Garuda. Garuda prepaid aku. Okay, you use as bottom as at the limit or replace gitu ya.
We just use bottom as for substitute fine aggregate. Yes.
Substitute fine aggregate for bottom X.
Yes. The calcium carbonate and carbon-base is for cementitious material.
Substitute also for
Cement. Yes.
so if you see from the about bottom S material chemical composition. So yes, iron
Iron oxide.
iron.
Yes.
Is it okay? Iron.
The amount of iron oxide for bottom us is just around about under 10% of chemical properties of bottom us. The most is SiO2, silicon oxide, is for 50%. Al2O3 as aluminium oxide is for 30%, and Fe2O3 as iron oxide is just about no more than 10%. The chemical properties.
You see that whatever is suitable to replace what's aggregate.
For us, bottom us is cannot be replaced all over the fine aggregates, because bottom us from the burning coal is having is really huge, and we have to crush it for about 10 or 20 millimeters for substitute fine aggregates, and we think it is a lot of process to do.
Okay, thank you. For the next jury, Mr. Irwin.
I will continue Prof with my question. Since you use bottom as a sand replacement analysis, how you ensure that it contributes on the chemical reaction in your concrete? Because this material has a sand replacement instead of cement substitution. Why you include this bottom S in the will you contribute to chemical reaction on your concrete?
So the bottom us, we think that bottom us is plays a role for the contributing second reaction that affected to mineral strain from this concrete. It's not for early stage, because the early stage we provide for carbon and carbon waste. We use biomass for reduce the waste material that should be polluted in environmental, but we use this for concrete that have a value.
So, what major contributing factor on your early strength?
The major material that contribute the high early strength is because cocoa tree and carbon waste is having a really huge amount of calcium oxide that contribute to calcium silicate hydrate and make our concrete more rigid and crystalline. Calcium carbonate and carbon waste have approximately around 50% of calcium oxide. So it will be really helpful for our concrete to have a high early strength. Especially this competition is for 1 day old plant concrete.
If you compare with the normal concrete, plain concrete without containing this alternative material, so you can conclude that these two materials really contribute on your early strength.
Yes, we have experience for using calcium carbonate for the other competition in University of Kristen Petra. We use calcium carbonate for about 2 kilograms for one molding, 2 molding, and that's have a result for 14 MPa in 28 days. 40 MPa, while the average of compressive strength that reach of each team, other team, is just around 19 MPa. We have a multiple this compressive strength about because we use calcium carbonate.
That's for 28 days, right?
Yes.
We are Mr. Iwan and us, all of us, are talking about 1 day. What is the contributing factor?
The calcium ion in calcium carbonate is the main reason that high early strength can contribute with our concrete to make our concrete 1 day plan is more higher than the normal concrete, because the normal concrete we already made for our trial too with the SNE 0368 2000, and the normal concrete it just only get 1 day strength. It was just 1 until the highest is just 4 MPa. And with this calcium carbonate and also carbon waste with the perfect of usages and dosages, it will be make this concrete more higher in early strength. And we are provided. We proved that in our laboratory.
Okay. You mentioned that you would like to create eco-friendly concrete, something like that, using eco-friendly material.
Yes.
What is the proof that your eco-concrete, eco-friendly concrete is friendly to the environment? Do you have any numbers of CO2 emission of your concrete compared to normal conventional concrete?
for that really number of exactly number, we are really sorry that we do not have. But in our reference or based on our journal, Maisarah Ali et al. 2015, replacement of cement by just 2% with calcium carbonate. It helped to reduce carbon dioxide emission from cement plants by 69%.
Yeah, but this is actually from the production, while life cycle assessment means that you have to assess during the whole cycle of the structure of your infrastructures. Also, when you what I mean is that I just posing an issue for this. Your life cycle assessment and your LCCA life cycle cost analysis only assess production stage. Can we go to the LCC analysis? This is only the production stage, not the operation of the extraction of material, the production, the transportations to the place, the operation, the construction phase, and the end. Yeah. So that's my issue. You don't have to answer that. My issue is that you have to think it over. Well, you said, well, you're saying that this is eco-friendly material. You have to make sure that the whole process during the life cycle of the material, you have the numbers, you have the, okay? Okay. Okay, thank you.
Thank you for Mr. Stella.
May I add in more? So the last is, this is a new approaches that we approve about the reducing carbon dioxide emission with increasing high restraint and also reducing waste material can be done in one innovation. So why will not proceed this research for keeping our environment more better to participate in sustainable development goals?
That's precisely my issue. You conceptualize that. It's only a concept. But you don't have the numbers. How much carbon dioxide emissions during the production, during the material extractions. Carbide waste is produced using carbide, and then a lot of processes going on before they have waste. This typical material have their own carbon footprint, number of carbon emission. You have to make sure that it's, practically speaking, get less and less compared to other material. Okay? It's just some kind of issue that you have to think it over while you're going back to Surabaya.
May I have some feedback?
Sorry, but the time is up.
Yeah.
Okay.
I'm sorry. The time is up.
Time is up.
Just 30 seconds.
No, the time is up. So the committee have to
Okay,
stop.
later I will come to your team and then we can discuss. Okay.
Thank you.
Thank you so much. We are counting Garuda. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, the juries, for the interviews, and thank you for being here.
Just a minute, bro. Just a minute.